Hi all, we are continuing with counting and probability today. So up on the screen I have the answers to yesterday's homework, question 4. Okay, so you can pause the video and correct those few questions. And skipping down then, I'll just pause here on this question 6. So this again, they're the question answers to question 6. And what we want to look at now today is a few different terminology. So we're going to start here in this point here with a bit of notes, and then we're going to jump on into a few questions and answer them. So, what we need to understand today is the difference between theoretical probability and experimental probability. Okay, so if I told you, for example, what's the probability of getting a heads, we'll say, if I flip a coin, and you'd probably tell me it's 50%. If I told you what's the chances of getting a 2 if I roll a die, and you'd probably tell me it's a 1 in 6 chance or 1 out of 6. So that is the theoretical probability. And really, what you're doing there, I suppose, without realizing it, is you are working out the number of outcomes that I'm interested in. So, for example, if I was talking about chances of getting a heads, then there's a one outcome there I'm interested in, which is heads. Out of the number of outcomes that would happen, so there would be 2 outcomes there. So that'd be 1 in 2 chance, or 1 over 2. Or if I was talking about, for example, rolling a die, it might be that I'm interested in the 2. So there's 1 outcome I'm interested in, and there are 6 outcomes in total, so 1 over 6. Okay, so remember, we always write probability in terms of either a fraction, 1 over 6. We could write it as a percentage, 16%, or we could say 0.16 as a decimal. So experimental probability is a little bit different, okay? So although, like, if we talk about a dice or a die, again, I always mistake the two of those. If you're talking about a die, and you roll a die, just because there's a 1 in 6 chance or 1 out of 6 chance of getting a 2, you mightn't necessarily find in reality that that is the case, okay? Because like in reality, it's just up to chance, isn't it? That's what we call experimental probability, okay? So the same with heads. So just because there's a 50% chance of getting a heads, doesn't mean that if I toss the coin 2 times, I'm guaranteed to get one of those is going to be a heads. So, say for example, if I toss a coin, right, and I repeat this 4 times, I might get a situation where I get a heads, and I get a tails, and the tails, and the tails. So, in other words, there's only 1 out of 4 um, of those outcomes are heads. So, that would be the experimental probability, the number of times the actual event happened, which is the times I've got a heads, over the number of trials, which is the number of times I've actually tossed the coin. So that'd be 1 over 4. So the experimental probability could actually work out as something like 25%, whereas we know the theoretical probability is 50%. So there's 2 differences there that I want you to recognize. Theoretical probability is just that, it's theoretical probability, which is the number of outcomes I'm interested in over the number of outcomes in total. Whereas experimental probability is basically the number of times the event has happened over the number of trials. So the words that you're going to see more often inside the book is what we call relative frequency. So relative frequency is another way of describing experimental probability. Okay. And one thing to highlight here is that the more times I do, the more trials I do. Okay, so if I keep flipping this coin, we'll say, like, I'm going to bring my experimental probability or my relative frequency closer and closer to 50%. It might never be perfectly 50%, okay, but it will be very, very close, especially if I flip the coin, we'll say, a 1,000 times. If it's a fair coin, then it should give you very close to 50%, frequency of a heads. So the final thing I didn't want to talk about, which is what we're going to encounter here in a few questions, is what we call the expected frequency. Okay, so if I know what we call the experimental frequency, or we could say the relative frequency, then I can multiply that by the number of trials to figure out what the expected frequency is going to be. So let's put that in context. Okay, let's imagine that we have a soccer player. Okay, and he has been his I made a mistake here. His relative frequency of winning a game has been 0.4. Okay, so in the last season, his relative frequency of winning games was 0.4, or 40% of games he won. For next season, we might be able to work out his expected frequency, and to do that, what we'd have to do here is we'd have to um, we'd have to take his relative frequency and multiply by the number of games. So if he played 8 games, then we're going to make a prediction here that he's going to win 3.2 of them by multiplying the relative frequency by the number of games. So 3.2 obviously makes no sense in terms of wins, but 3 wins would make more sense. So let's pop on now and let's have a look at a few questions. I'm going to go through 3 questions with you today, 2 together, I suppose, slowly, and then the last one then will be a bit more quickly. So let's say I have a die and it's rolled 100 times. The number 4 occurs 35 times. Find the relative frequency. What it's basically saying is find the experimental probability. So let's label a few of these things. A die is rolled 100 times. What I'm doing there is I'm doing 100 trials. Okay, so that's 100 trials there is what I could call that. The number 4 occurs 35 times. So this is the event that we're interested in. So we're interested only in the number 4. So let's fill in that information now and find the relative frequency. So the number of trials, as I just said, was 100 times because we've rolled the die rather 100 times. The number of events, so we have ended up getting 4 35 times, so therefore that is my number of events. So the next thing we need to do now is we need to work out here the actual values here for the relative frequency. So what you should know again is your relative frequency. So relative frequency is going to be equal to you're using this formula. So the number of events, okay, so number of events over the number of trials. Now that's slowly catching up with me there. Number of trials. Right, now this, hopefully that'll appear on the screen. Number of events over the number of trials. So let's write this in now. That is 35 over 100. In other words, that is 35%, or you could say it is 0.35. Okay, that is the likelihood of getting a number 4 on the die. Okay, so that's the likelihood. So I'm going to write that in there as well, so we're all perfectly clear on that. So the that is the likelihood of getting a, rather, you know what, that's the relative frequency, that's the actual probability there. So we could say there is chances of getting, or relative frequency of getting a 4. Okay, and that's what that is. So just change the color there just to highlight that one. What if I wanted to work out the relative frequency of not getting a 4? Well, what I would do then, and that's the second part there, it says not rolling a 4. What I would do is take any one of those frequencies. So for example, I'm going to take 100%, and I'm going to subtract from 100% 35% to work out the chance of not getting a 4. And what I'm getting there is 65%. So 65% is the answer there for not getting a 4. Okay, so again, I'm going to scroll that down there. So in other words, of not getting a 4. Right, I hope that has made sense so far. So that is how we do the first question there. I think that was pretty straightforward, question 8. I'm going to skip down now to question 11 and study this one in a little bit more detail. So last season, Jonas scored 12 penalties out of 18. What was the relative frequency of Jonas scoring a penalty, first of all? And if Jonas takes 24 penalties next season, estimate using relative frequency how many times you would expect him to score in this next season. So let's start with what we know. Jonas scored 12 penalties out of 18. 18 in this case would be the number of trials, and 12 would be the number of events. So in other words, what we're interested in is how many penalties he has scored, and the trials is how many times he's kicked the ball for a penalty. So let's change this information. The number of trials we just worked out, which is number 18. And the number of events is how many times he's actually scored, which is 12. What we want to do is we want to use this formula again, and we want to figure out his relative frequency. Okay, so let's rub out what we have there and get rid of this. Right, I'm going to use this formula again, as I said. And what I have here is the number of trials. So the number of trials we know is 18, and the number of events, so it's 18. No, made a mistake there. It's not 18. It is 12 over 18. So 12 out of 18, when you work that out in the calculator, you should find, or even to simplify it to 2/3, you will find that it is 0.67 as a decimal, or it is 67%. 67% is the answer for that one. Sorry there, that's catching up again for me. Right, 67%. Right, so that is his relative frequency. So going back to the question then, again, it says, if Jonas takes 24 penalties next season, estimate using the relative frequency how many times you expect him to score. And this is what I was talking about earlier in our notes. This is the expected frequency. So what do we expect? Well, we have to use our formula here. Okay, and our formula, as provided there in your set of notes there, was equal to the number of trials times the relative frequency. Or you can do it the other way around if you'd like, same difference. Okay, right. So the number of trials this season has changed. Okay, and in the question there in the book there, it says he has now taken 24 penalties. So that is his number of trials is in other words 24. Okay, so we have 24. And that's going to be multiplied by the relative frequency. So you can multiply by 67% if you'd like, or you can multiply by 0.67, or you can multiply by that fraction. Okay, and what you should get for that is a value there of 3.02. Okay, so we have a value there of 3.0. Hold on, no, sorry, that's the next question I was thinking of there. That is 16.08. Obviously, 16.08 makes no sense. You would round it to 16 because he's going to score 16 penalties. That's what we expect him to do. Okay, so hopefully that one has made sense for you, and it should definitely help you now with the next question and next and final question will be talked about in this video. So we are told this. The color of 500 cars that pass a particular set of traffic lights during a 2-hour period is recorded by a group of students. We're given the color. Okay, so we know the color breakdown, we know the frequency. We are missing a lot of these relative frequencies, and then we want to work out what we call the daily frequency. Okay, so what we could do here is we could work out what we could work out here is the let's see, the first thing here, calculate the number of black cars and write it into the table. Well, that would be easy because you know the total number of cars is 500, and all you have to do here is add up all these other types of colors and subtract from 500, and you should get your black color. Okay, we then want to work out the relative frequency. So the relative frequency, remember, is the number of events over the number of trials. So the event in this time is like the color, the amount of cars with that color that have passed over the total number of cars. So in this case, it would be 70 is going to be the number of events, and that's going to be divided by 500, and you should get a value there on your calculator, 7 over 50, or 0.14. So that's where that came from there. You repeat this process for every one of these numbers. So the next one there is going to be 100 divided by, so that's the number of trials, divided by 500, and you will get a value there again of 100 divided by 500, which works out at 0.2. Okay, all of these relative frequencies, if you've done it correctly, should add up to 1. Okay, so that is how we do part B. Okay, I'll let you figure out part C yourself. What is the probability that the next car to pass the lights is red? So again, I'm going to let you figure that one out yourself. So in other words, talk about the 501st car. So what is the probability that that car is going to be red? Right, this part E here, use the information to estimate the frequency of each color if 2,400 cars pass the lights in a full day, and calculate this information into the table. Right. So what they're basically asking there is to work out the expected frequency, okay? And I want you to work this out, this expected frequency, just for what they provided there, which is 2,400 cars have passed in a full day. So what you would do, remember, is you take your relative frequency and you multiply by the number of trials. In this case, it's going to be 2,400. So what you should have is 0.14, take your relative frequency, multiply that by 2,400, 2,400, and you will get a value of 336. Now you will find here, actually, guys, there's a mistake in the book on this one. This should be 336. Scratch out 3.36. And then what you should find is all of these numbers should add to 2,400 on that. Okay, so that is your work. Your questions will be assigned in Google Classroom, and hopefully that has shed a lot of light now on how to work out your theoretical probability, your relative frequency, otherwise known as experimental probability, and finally then your expected frequency.